all the time, huh? This is what is in front of you is what? 1 by 2 decode. What is this?
2 by 4.
What is this?
3 by 8.
What is this?
It's an n-bit decoder.
Right? Now, I give you something and I would like you to practice this thing, right? I asked you to use what? The for generate, right?
Right.
So for generate, that means, we have to use it. I didn't say make it completely flexible, right? I just say flexibility, right? Now, first of all, there was a part in the lab. I said that you're going to put like a decoder on the board and you will just like present it, right? That should be easy, right?
Yes.
So now
mean
we
like
have
explain
something
the-
done, right? So the part of the lab, let's say that, the board we have, do you agree, guys? How many switches we have?
16.
16 switches. We have here 0 to 15 switch. How many LED we have? 60, right? So 0 to 15 LED, right? This board cannot go for n by n by 2 power n decoder. Do you agree?
Yes.
So we have to define like the ceiling, right? So I said in the make it easy for you, you're gonna make it 3 what? My 8 decoder. Do you remember that? That means 3 switches and 8 LEDs, right? That makes sense?
Yes.
Okay, thank you. Now, this part, it should be clear to everybody. Do you have any questions so far regarding this part?
No.
Cool. Now, let's go into the how to design something with full loop, right? We said that, the component we have in our hand is called what? 2 by 4, right? So far, so good?
Yeah.
Okay. So now, 2 by 4, it's a unit. If I would like to make it 3 by 8, what should I do? I will do it like this. 1, 2, 1, 2, 3, 4. 1, 2, 3, 4, right? And here's something. Right? Then, color-wise, that will be like this. Right? Then, this go like this, and this will go like this, right? And then it will be a wire here, right? So S0, S1, S2, and then, we have here what? The first 4, the second 4. So far, so good?
Yeah.
Good. Now, this is the enable, right? Those are enable. And for simplification, it's gonna be what? It's gonna be not gate like this, connected like that, right? Does it make sense?
Yeah.
Okay, so can we use for loop here?
For 3 by 8? No.
Yeah, we can use for loop, right? It's gonna be 2 loops, 2 iteration in the loop, and this block will be running like this, right? Huh?
Yeah, I see what you mean. Like one for the amount of levels the tree has, and the other one's for the amount of I guess decoders.
Yeah.
So the first loop will be the enabler, right? That chooses which one is on.
I didn't say, I'm just asking, to make it almost like this full adder example, right? There are 2, I instantiate 2 blocks, right? But I don't want to put them by my hand, right? So how I'm gonna do it? For generate, and the block here in the middle, and I will be generating, right? Do you agree?
Can you give me that one more time?
Again. Let me tell you something, one second. This 2x4, right? Did you see it? This 2x4. Is it possible for me to call the inputs I and the output P?
Yes. Yeah.
And I can call it what? I 1 to 0 and P 3 to 0. Nobody will say anything about this, right?
No.
Okay. Now, when I will build the for generate in this case, what should I do? I'm gonna be instantiating this block inside the for generate. Do you agree?
Which
Then
block?
I will be sure that there is like index of the for. The for is one dimension, right? So that index will be what, moving from 3 to 0, and the second time this one it will be what, 4 to 7, right?
Yes.
So what is the jump happen here? If I equals 0, this will happen. If I is equal 1, this will happen, right? So you can figure out indices, how to make it I plus something times something, and you will figure it out, right? This is not circuit. This is what fundamental logic, right? We can look at it. Anyway, so what about if I move to 3/8? Let's look how this 3/8 will look like, right? This is 3/8. What about if I would like to have 4/16? Do you guys agree? 4/16, how gonna look like? So gonna be a 4 blocks, right? Make sense? Then 1, 1, 1. Those are the 2 bits, right? The first 2 bits, basically, right? So if I go like this, right? How many blocks now the for loop will be generating? Hello?
4.
Exactly 4. But then there is a new level here. In this case, it was just not gates going in like this way, right? Now here it's gonna be what? A new
Another decoder.
exactly 1, 2, 3, 4, 2x4. So this is the iteration, right? A new iteration that will make what? This go in this gonna go in this, they're gonna go in this, they're gonna go in this. Do you agree?
Yeah.
Okay. So did you see? You can, if it's hard for you to make it completely flexible, what you can do, you can come into this and you just use the for generate here, right? Did you hear me?
So then how would we incorporate that other decoder into our code?
You are thinking about the full flexibility design, right? Because if you are not thinking about full flexibility design, you will just say, yay, I will have a full loop. One time it will be making 2, but sometime when I will need a new parameter in my head, it will be 4. Then those can be manually made if it's really hard for you to incorporate it, right? But then, you prove to me that you understand what is for generate, which is basically the outcome of this lab. Do you agree?
So we could use like a if else statement.
You can make if statement, but you don't need if statement. It doesn't matter. You can just come and say, Professor Ali, you would like us to show you that your for generate is working, right? So we decided to give you the prototype for 16s. Look, we use 4 generates, run those 4, and we made this internally by itself. So we proved to you now we know how to replicate blocks using 4 generate, and that will be enough. Kevin, it's up to you. But I'm saying, the example, you understand what is, you have to know that everything I give you, it has a reason, right? So what is exactly I would like to see from you as a lab 1? First, you use git level, you build the 2.4. Second, you know how to use test bench to test it. Third, you know how to connect El-Hadedy and what switches and run sentences until you will put in the platform. Fourth, you show me that 4 generators work. That's basically what the target from this lab, right? Make sense?
Yeah. Professor, just to clarify,
Yes, sir.
you're not necessarily asking us to create a completely flexible n-bit decoder.
No. Fully flexible is coming soon, but not
Okay,
now.
cool. You
Yeah,
just
that's basically what
want
I
us to show you that we're able to use 4 generate to create a more than 2-bit decoder.
Thank you. From the 2.4 base. Wait. With limitation, you are using the 2.4 is not flexible. By the way, if you go behavior, you can make it like this. Do you understand what I'm saying? If you go in a behavior modeling, you can make it full flexible, much better than that.
Is when you mean behavior modeling, is it where
Behavior model, like
let-
assign with whatever, and
Oh,
all
I see.
blocks and so on.
Okay.
I didn't give it to you yet, right? So that's what I'm saying. But the idea, think really deep and far from just like make an assignment and get the grade. This guy spent amount of time of telling us 4 generate. So basically, he has to see that 4 generate is working. This guy is telling us git level is like this. So we have to show him that git level is working. This guy, give us something is called test bench with environment that it will test the module that it will go on the chip. So it has to be like this. Oh, he also would like to know that, we understand that we can run program that it will be deployed on the chip. So like this. So when you give me this, that means thumbs up, indication you understood the message, and I will move forward to the next. Make sense? Is it clear? Hello.
I just have a question. So our unit 0 per se would be the 2x4 on the left, and the 4 generate would be on the right.
I mean, whatever you want. That's what I'm not 1 second. When I made like this, it doesn't mean that follow this. I'm giving you flexibility. This course, it doesn't have one solution. You can have infinite solution. It's a design course. You know what I mean? Design is based on the design. That means, I give you regular, formal regulations, instructions, but, I leave you as a future engineer to give me your idea. Okay. Anyway, let me show you something. So 416 like this, right? What about 532? How gonna be? Huh?
Use a 3x8.
Exactly. So gonna be what? It's gonna be 1, 2, 3, 4, 5, 6, 7, 8. So this is very straightforward, right? But the second level here is no longer 2x4.
Yeah.
It's gonna be what? 3x8,
3x8.
which is also can be what? Taking this and put it inside this level.
So we can use like as many 4 generates as we want.
Exactly. You can have one for, it is obvious from what I can see in my eyes now that, end of the day, it is 2 levels. You can make a 4 generate for a level, passing to 4 generate to another level, right?
Yeah.
Does it make sense?
Mm-hmm.
But, did I say that, as much complicated, I will give you better grade? I didn't say that, right? So you do the bare minimum that will give you the grade, right? which is you prove to me that you understand for generate. You prove to me that you understand instantiation. You prove to me that you understand what this parameter is. You prove to me that this bench. You prove to me that the board is working, right? Sounds good to everybody, or something is not clear?
Sounds good to me.
I will wait until 30 students attending now to say it's clear. If it's not clear, I can repeat. I don't have any problem.
Professor, could you please like go over the code too, like not like exactly, just how it
Yeah,
works for
That's
with
what I was gonna
using-
ask as well.
Yeah.
Wait.
The concept, I understand the logic of it. Just the coding is just sometimes I don't know, like I'm doing it right, or where you doing it. I don't know if you could go over the code, like
I can fix it too. So
Yeah.
basically, the decoder, right? Decoder 2x4, right? So we already made it as a gate. Do you want me to do this again?
no, I can do that. Yeah,
Okay, so you already have the .v, right?
right.
Of
Yeah.
the decode 2x4.
Where 2x4, right?
We have it here, right? So let's imagine that this decode 2x4v, it has input and output ports, right?
Right.
So let's call it like input 1 to 0 I, output, right? 3 to 0 P, and then input, right? En. That was the ports, right?
Right.
I'm not gonna write like a formal syntax. I'm just telling you the trick, right? And let's call it decode 2.4 whatever, right? So now I would like to build the 3.8 in the bigger file of 3.8 from the 2.4, right? So what I'm gonna do, I'm gonna instantiate the block, right? So instantiate the block, it will be what? It will be decode 2.4, and that decode before here is space, and then I will give it a name. You remember? So I will call it what? Comp. Just call it comp, right? Then I will just have a space like this, and I open the parentheses here, right? And they're gonna be what? It's gonna be .I and something here, comma, .p something there, comma, and that will be en and something there. So far so good.
Okay.
That's instantiation. Do you agree? Now I need to instantiate it how many times? 2 times. Do you agree? So I put here what? Gen var I, which is I generate a variable that will be used as an index, and this variable is integer, right? Then I will write what? I will write generate. Then I will write here 4. Then I will write here whatever, begin, end. Then, I don't remember the thing, but it's gonna be in generate, right? Generate or something like that, right? Then, the 4 is gonna be like this. It's gonna be I equal. What do you want I to be starting from what? Whatever you want.
1.
0, right?
Okay.
0, comma, I less. It is, in this case, we want it to be what? 2, right? Let's just stick with something simple. So gonna be what? I less than 2, right? Comma, I equal I plus 1. So far so good? Okay. Now that the wire is coming is basically the input of the decoder 3.8. Do you agree? Do you understand what I'm saying? Hello?
I guess. It's coming from that decoder 2x4, right?
I'm using 2x4 to put 3x8. So
Okay.
3x8 file.
Okay, yeah.
You guys understand what I'm saying, right? Hello?
Which wire specifically?
When I say 3x8, that means it has input and output, right?
Yes.
So, here, those guys written inside the file of the 3.8, right? So I instantiate this guy inside 3.8. Of course, 3.8, it has his own input and output, right?
You're right.
Correct. So imagine that, you know, the input of the 3.8 is called V, right? And the output is called W, right? So, you know, output here, for instance, is like 7 to 0. And the input is basically 3 to 0.
2 to 0, no?
2 to 0, yes, you're right. Right? Correct. So now, you know, I'm gonna say what? V, and I open like this. W, and I open like this. Here, this, like this, right? So far, so good? Now, I need something here and something there, something here, something there to fix it, right? To be what? Aligned with I, right? So we said, you know, when I equals 0, I want here to be written what? 0 to 1. Correct? And there, you know, it's gonna be 0 to 3. Then, you know, when I is equal 1, that's gonna be 0 to 1 also. Then this will be 4 to 7. No, that's gonna be, yes, you're right. Yes, correct. Okay, so it's basically that's gonna be 1 to 0. Okay, because if you notice, no matter how I change, this guy is still 1, 0. Right? Do you agree?
Yes.
Perfect. Then, you know, now the changes is here, right? So if I have here I want when I is equal 0, I think, time 4. And there I is equal 1. When I have 1, what will happen? Wait. When is 0? I want it to be 3. When is 1? I want it to be 7, right? So what is the equation can do that? Do you have an idea?
4 times I plus 3.
Plus 3 plus I times 4, right? Correct?
Correct.
So it's going to be 3 plus I times 4. Here. Okay, done. So far, so good. And then, you know, we're going to create here in the middle here temp. And that temp is what? Two bits. And we're going to call this what? Temp I. Are we done? We are not done yet. You know why? We're going to go here after the in generate. And we do what? Assign.
What is that you put in the EN?
Temp. I made a wire. It's called temp.
Oh, okay. Yeah.
And that's
Or-
before the generate, correct?
For the enable.
I see it. Okay,
Because, you know, do you remember we had 3 bits here, right?
correct.
3 inputs, right? 3 input and out.
Correct.
You know, the temp equals 0. It's gonna be something, right? So assign temp 0 equal, and then assign temp 1 equal, right? When is 0 gonna be what? It's gonna be negation of the V2, right? When is 1, it's gonna be V2. Done. I made a mistake, actually. I flipped it. It shouldn't be like that. It should be here. Assign V2 equal temp not gated. That's it. Any question? No, I'm wrong.
I think the way you had it in the beginning.
Yeah, where I had it in the beginning, it was correct. Yes, but it shouldn't be two of them. It should be, yeah, it should be the same. Yeah, right. This is correct. The way I made it in the beginning was correct. How much time did it take? It took maybe 10 minutes. I don't know. While we are repeating pieces, right? Now I prove to everybody that full generate is working in the context. Do you agree? And I built 3.8 out of this. Any question? Guess what is the only trick in the whole entire thing? Somebody can tell me. Point to me, where is the trick?
The bridge.
Yes.
Oh.
That was the only trick, right? Right? That was the only thing, which is not at all related to 3300 or even Verilog. It's what programming level. You guys took C, right?
Yeah.
C for engineers.
I think what confused us all was just the
Stability.
how to connect it like with the wire.
The
At least that's
enable.
the part that kind of confused me.
So now you guys, when I meet you in person, everybody will pay me $5 before tax. It's easy, right? I'm joking. You don't need to pay anything. Okay, is it clear? Seriously, is it easy or not? Tell me.
Can you explain the assign temp 0 at the
Okay. Let's make this more difficult. I love difficult stuff. What about if I would like to build from the same circuit this guy? How I'm gonna do? Extend this, right?
Is that what we need for a parameter? Like that number 2 will be the size of a parameter, right?
Exactly. Right. And of
But
course,
now would the
this will be
I,
the same.
so would the I be less than size or size minus 1? It just be less than size, right?
Yeah, but I mean, I'm not gonna.
Which is the size?
It's supposed to be. It's your assigned, guys, not mine.
Correct.
Anyway, but you understand what I'm saying, right? So this value, it has a connection with the story, right? So that's this one and this one. They have a rule in the game, right? You agree?
Do you mind repeating that, Professor?
I have a question for you. This temp is representing what for us?
or enable?
Exactly. And when it was 3.8, how many I enabled them?
There were 2 enables,
Okay. In the 4.16, how many I enabled?
4 of them.
So there is equation, right?
Yep.
When it was 3, it became 2. When it was 4, it became what?
4.
Right? When it's 5, it was what? 8. 2, 4, 8, 16, 52. Right?
Right.
Sounds cool. Verilog part, let's break the problem, right? Verilog part, writing this piece, right? The rest is what? Doesn't have any relation with Verilog. Doesn't even have any relation with what? Digital logic. Because what is digital logic in this game? Huh? Where is it? To know how the decoder look like. And that was the job of the digital logic design 20 CM. Verilog to know this. The rest is what?
Simulating.
To make the communication. Yes. Which is basically playing with this kind of equations, right? Sounds good to everybody? Do you have any question? If nothing is clear, tell me.
I got a question. On the wire, you have it circled, that's 1:0, right? 0 to 1, right? Okay, so then in the enable temp, you put I. So let's say it goes to 3, for example. I don't understand how it could go from 0 to 1 on the wire, and then it calls for 3 in the for generate. I wouldn't know to do
Can I
that.
raise my hand? You know, when that was 1, this is less than 2.
Okay.
What does it mean less than 2? That means this indicator will count 0 and 1, will never reach 2. Because the for loop in C, when this is 2, I less than 2, and I became now 1, it's still fine. When I will be 2, the whole for loop will never happen.
Oh, I thought that 2 was like rhetorical. Or no, that's necessary then, right?
Okay. Let's say now, you know, I is 3, you know, let's say this is 3. So this I will be what? 0, 1, and 2, and 3 will never happen. Right? So if wait, if I want this to be 3, so what is this will be?
2.
Exactly.
Oh, okay.
$15. Okay, anything else, guys? Tell me. Any question? Hello. Hello.
No questions.
Okay, let me take it one by one because you know I like to be sure everybody understand what's going on. Okay.
I have a question.
You can have 2 questions.
Kind of regarding to this.
Yes.
But I'm using like an if else statement because I'm still trying to do it fully flexible. And I was wondering if we have a statement that takes a binary and a decimal number and compares them, and if they're equal in decimal, will it?
I will tell you something.
There's-
You know, you're thinking way above, which is good. If you notice, because I give you limited stuff in the lecture, right? I'm just trying to use whatever I give you, right? Well, the reason, because later on when I will start adding more, we're gonna revisit again this and we will build it flexible. So, you know, the whole entire idea that I'm following, give you something, be sure that you already got it, and give you something, and something, add something. By end of the day that, you know, everything will be sticking in your head. Make sense?
Yeah.
So let's take it step by step, okay? Okay, so before I give you the new lab instructions, is there any question? Can we get an extension for Friday? For what? You can just do it now, right? I wrote the code. You can just make one, right? Are you guys looking for any extension?
That would be greatly appreciated. Yeah, I have a lab till 9 o'clock after this class.
I will give you this time extension till Friday.
Thank you.
Thank you very much.
Sounds good? But still, you're gonna take the lab for the next week. I will give it to you now.
Of course.
Sounds good? Here, lab extension. to Friday. Midnight. Up to midnight Friday. No, I don't need any money. Hey, dude, no. I wish actually I can help you guys to get a really, really high salary. Anyway, so Friday, you know, they're gonna be February 11th. Okay. Before I jump to lab 2 assignment, any question?
So I get everything. I understand. I just what is it on the sign temp? After all the way down. So it's a sign temp. 0 equals not V, and then what's in the bracket? Is that a 2?
What do you mean? This?
Yeah.
I mean, I'm just
I
writing
just
anything.
couldn't read it.
0, 1. I mean, I'm just, you know, my writing here is not like the exact thing you're gonna do, right? My writing here is just the idea,
Correct.
right?
Right, so what's the concept of it? Are we just linking that one to the next input?
No, I will show you. This is the concept,
Okay,
right?
Yeah, it's calling the like the enabler.
yeah, okay.
Yeah,
okay.
to see which
This is your temp.
bits.
It's linking
Yeah.
it.
Yeah, the temp 0 is enabling from 0 to 3, right?
Yes. So
Yeah,
you
and
know,
temp 1 is
this one
enabling
going
from
like
4 to
this.
7. Yeah.
Okay.
Sounds good.
Yes, that's very helpful.
Sure. What about the rest of you guys? Any question?
I have a question. It's more on the Verilog rather than the concept. I understand the concept. For the assign, is it not sufficient enough to just say temp sub 0 equals V sub something? Do we need the assign?
You know, first of all, why we have a sign? Why the Verilog maker made a sign?
I'm not
Like
sure.
a continuous
why.
assignment.
I will tell you why.
Connect wires.
Populate
I'll
all
tell
the
you why.
nodes.
Now you know to push something into a different level, right? Either that you will have something to store it, or you know you will force if physics, or like you force movement in the wire, right? So you know to store it, that means that guy will be what? Reg. Do you remember?
Yeah.
But this guy is what? Wire.
It's wire.
Right? So in a wire, there is no location to store the value, right? So what you are doing, you are forcing.
Okay.
Right? So the force for us is what?
Assign. Okay.
So I'm asking literally wire. If you see any value changing in this guy, dump it there.
Okay.
Make sense?
Yeah, it makes sense now. How so? Just to clarify, if the wire were a register, we wouldn't necessarily need the sign.
No, it's just so we're gonna use what always
Yeah.
at, and then you know gonna start here. But I haven't talked about this yet.
Okay.
Okay.
All right. Sounds good. Thank you.
Perfecto. Any other question? Should I start with the lab 2, or do you have more questions? Hello.
No questions, Professor.
I cannot move to the next part until everybody will give me thumbs up in the chat, or you know, thumbs up in the thing, or whatever. Feel free to give me thumbs up if you don't have any questions.
One quick question on the Verilog. We have to include the enable in the base code of the 2x4.
What do you mean?
So that you know the code you gave us in the very beginning, where you did the NOT gates and the AND gates.
Yes.
Do we have to include the enable in those?
What do you think? Do we need it or not? Do we need it?
I think we need it.
Yes, we need it.
Okay, so that changes our base.
Exactly. So we need to, that means you have to make the modification, right?
Right.
Okay.
Right. Got
Any
it.
other questions? Any question? Hello? No question. Lab number 2. Lab number 2. I'm not gonna go again and tell you what is the report and whatever. You already know that you're gonna stick with us forever, right? When is the due for lab number 2? So today, Wednesday, 9th, right? One second, stay with me, guys. 1 second.
I can come back if you're in the middle of something.
I'm teaching. So those actually the things that you want.
Well, I need to unpack them then.
See, that's the problem.
You know, Quinn, on your quad computer, purchase your quad computer.
Which one?
You have a quad computer.
Oh, I took the picture and I sent it.
I need to see it real time.
Oh, if I put it at home, at time when
You can zoom from home.
We can zoom to tonight or something like that.
And then this is what? Is this?
This is the tensor thing that
The
you are
tensor
the
X?
GPU.
Okay.
And this is the scope.
The bioscope?
Bitscope.
Bitscope?
Bitscope, yes.
Bitscope? Is it a server?
Yeah, it's a server of Raspberry Pi.
I'm just curious. It's a big server.
Yes.
Okay.
Okay.
I'm asking them. I trust there's something in the box.
No, here.
No, that's pretty.
I mean, I haven't opened it.
No, that's fine. Can you zoom from home?
Yes.
Okay, please do.
Should we do it today if you want?
Yeah, when you going home?
8 p.m.
No.
The tomorrow?
Well, I'm see, tomorrow, yeah.
Tomorrow.
Tomorrow's fine.
Let me know at any time you want, okay?
Okay, I'll send you Zoom.
Sure.
Thank you.
But those,
Mom.
you know, I don't know how can I move them. But...
No,
See?
I just need to see him, that's all. Thank you.
Thank you. Have a good one. Ah. Hello, back to the future. So, okay, now we are doing what? Hello?
Lab 2.
Lab 2, exactly. The deadline is what? February 16th, no extension. Okay. Same delivery, right? But what is the topic? The topic, tricks on using components to build other components. What is this, right? Do you remember the one bit full adder?
Yeah.
Yeah.
Do you remember the n bits? N bit full adder?
Yes. Yeah.
Exactly. We're gonna use the same thing, but the one bit full adder, we're gonna build it using what? Majority encoder plus 2 XOR gates. Did you do that?
Yes.
Yes.
I'm gonna show you everything and then we will be done. Okay. So one bit full adder. What is the design in one bit with full adder from your point of view? So we have to do what? The two stable, right? Sum, carry out 1, 2, 3, 4, 5, 6, 7, 8, right? 0, 1, 0, 1, 0, 1, 0, 1, 0, 0, 1, 1, 0, 0, 1, 1, 1, 2, 3, 4, 1, 2, 3, 4. Right? Let's add them. So it's gonna be what? 0, 0, 1, 0, 1, 0, 0, 1, 1 0 0 1 0 1 1 1, right?
Yeah.
Okay, this one is what is XOR, passing to XOR, and has the A and B and C in. Do you guys agree?
Can you go down a little bit?
Here. That's from the 2300. You remember that?
Yes.
Anyway, this one is the most exciting one. What does majority encoder mean?
Output's a one if the majority of bits. in
Majority
are
of
one.
exactly. We discussed about this for the in the lecture, if you guys remember. For those who didn't attend the lecture, you know, I will pass it to you guys. But anyway, I mean, for those people who attend with other professors, I believe. So majority encoder is a box. You look into what is the wires of the inputs has, and you decide what is the output. For instance, if I'm looking for majority of ones, so that means, you know, if number of inputs having ones more than number of input having 0, the output will be 1, and the vice versa. Let's look. Here, 0, 0, 0. How many ones here?
None.
So none, 1 compared to 3 zeros. So who's the winner? 0. 2 zeros in front of 1, 1. So what does it mean? 0. 2 0. Now 2 ones in front of what? 1 0. Who is the winner? Make sense?
Yes.
Perfect. So, you know, end of the day, you will need to build a module. It's called majority, right? And this module, you will build it with 3 inputs and 1 output, right? The way that you're gonna write the code, you're gonna use what? Structural plus data flow. That means you're gonna use a sign form. Okay, with the logic, like, you know, the logic, this is not gate, this is an OR gate, this is AND gate, and or not gate. So far so good. Then this one, after you finish it, you will instantiate it in the 1-bit full adder to be connected to the carry out, right? And you will add this into it here. Then you know that will be the sum. Here is gonna be carry out. And then you know you will go in the for generate that I made for 1-bit full adder. They're gonna be in bit full adder. Does it make any sense?
Yes.
Okay. Write down here because, you know, sometimes you guys forget. 1, design majority encode 3 by 1 using structure modeling with data flow, which is assigned, is it? 2, instantiate the majority module into the 1-bit full adder module plus adding required X, or they're going to be a gate level, okay? Gate level to generate both sum and carry out ports, right? 3, instantiate the 1-bit full adder into the n bits full adder. You have it before, right? 4, map 8-bit full adder out of the n bits into the XDC for generating the circuit. 5, do not forget the test bench with the all possible corner cases. We're done. Any question? Easy lab, right? Hello.
Professor, can you scroll down a little bit?
Hmm?
Can you scroll down a little bit? Thank you.
Don't forget, this is recorded. So I'm gonna post the record on the module 3, week 3 under modules, right?
Professor, what does it say for number 4? Map the into
So
the.
you're gonna, you're gonna map 8-bit, right? So that means you have n-bit, right? You're gonna parameterize it to be 8, right? Then you connect the ports of input and outputs to the XDC, right? You remember that?
Yes.
Can you go to number 1 and 2 again? Thank you.
Sounds good.
Yes.
Outcome of this. Outcomes. 1, practicing more into instantiate blocks with different modeling. Our example, it was gate level, right? Plus structure with data flow, right? 2, practicing more into test bench plus corner cases. 3, realizing more circuits on FPGA. Make sense? Then after that, we'll start making more and more difficult stuff. Okay, Luke, any question? Are you guys enjoying this course? I hope so.
It's certainly challenging, but I guess in a good way.
Good. In that case, I can say that we are done for today. And feel free if you have any question to ask. If not, it will be a great pleasure to see you guys on next week on campus.
Thank you, Professor. Appreciate
Have
it.
a wonderful
Thank you,
weekend.
Professor.
Stay safe and God bless you. On Saturday morning, I will start looking into your submissions, okay? For the lab 1. And then I will post the grades on the Canvas so you can guys see it, okay? Thank you.
Thank you, Professor.
God bless you. Bye-bye.
Thank you.
Jared, can you please stay? I need to ask you for something.